Okay, so what we're going to be going over today is just a test review, right? So I'm going to go over the one that the professor provided. Usually this is always a pretty good estimate of what's actually going to be on the test. I wouldn't say there's too much more of almost anything that's going to be on the test that wouldn't already be on this review. So the plan is just kind of just go through it one by one. And yeah, we'll see how that goes. Obviously, what I'm going to do is every time we get an answer, or we make our own answer, we're going to write it down right here. And in the end, you should be able to review a solution sheet online eventually with all the answers that we've accumulated through the sessions. So it should be as simple as that. Okay, so I guess we can start out. We have our first question here. Write a complete program to print hello and darling on 2 lines. So how I'm going to do this is typically, I'll ask the questions, and you guys want to try to see you guys try to get them right. And so, however you want to do it, yeah, we'll just want to see how you guys. So, where do you think I'm gonna actually, let's actually open up our IDE, and I'm just gonna delete everything here. So yeah, what should be the first thing I should be doing? All we got to do is write a program that types hello and darling on 2 lines. What should I do first? Yeah, same old, right? Just always include your Iostream. And then we're going to say using, oh, there we go. Say using namespace std, right? All right. So for those of you just joined in, all we're doing right now is going over the first question on the test review that says, write a complete program to print hello and darling on 2 lines. So we just need to find out what we need to actually type in order to do that. What is it, everything that we have to type to make this complete program? So far we have including Iostream and using namespace std. Okay, what's after that? Yeah, the include main. Sorry, not include main. Int main, right? So we have our int main function. And now what are we doing here? Right. You just use cout. And this part's pretty self-explanatory, right? You just kind of do the cout, and then you say, what is the sentence? Yeah, hello, darling. Okay. Hello. And there's obviously a lot of ways you do it. You could do it like this. And then another line you could say cout, darling. You don't have to do it like that. You could have done it like this. Put darling right there. Or, of course, you could do it like this. And del. And then darling. So there's so many ways you can do it. You might even say there's probably an infinite amount of ways you could do this program. Probably is. But usually the simplest. So this is what we got going on so far. Okay. Yeah. Pretty good. So that would be, there's one more thing we need. What do we need after this? return 0. Perfect. Return 0. Okay, so we got return 0, and that's basically it. You need the include Iostream. Yeah. If you want to make it a bit simpler, right? This is the bare bones of every program. And this is really all we're adding in order to make it do a specific thing, right? So let's copy that. And hopefully this will paste. Doesn't paste how I want. So I'll just take a screenshot instead. There we go. All right, so now what is going on? I want to just let me type normally. It should give me edit mode right now. Oh, I think I know what's going on. Okay, fine. Whatever. Okay, so now we have write a complete program to read 2 whole numbers, no decimal point, and print their sum and difference. Okay. So write 2 decimal points. Okay, fine. Here we go. So first, let's just work on the read 2 whole numbers, right? So we have our program. Okay, at the first, we don't even really need to change anything. You just get rid of this, and we already know that a whole program should have this part, right? We already know it should have this part because this is the bare bones of any program, right? And so then all we need to worry about is now reading the whole numbers. Okay. So we got to read 2 whole numbers. So what should we do first?
Define the variables.
Exactly, yeah. I'm glad you said that one. Sometimes people miss that one. Int a, we could just do int a, int x and y, whatever we want. We could do int a and b, right? Good. Okay. What do we do next?
You give it its parameters. I can't remember what it's called. Then I can't remember. I'm sorry.
The kind of similar to the cout except cint, right? So we go cin. Oopsie. I'm going to point to a, right? And you could do like that. This would be maybe a simple way to do it. Most people would probably do it like this. CMB. Right? So basically all that's happening here is this time we're taking input. This means input. And we're directing it into the A variable. Then again we do it again. We take input and direct it to the B variable. Right? So those 2 lines, right? Alright. We've now read 2 inputs, right? These are where the reading happens. We read input. This would be reading input 1 and reading input 2. Let me check. Let's check what this says. And then it says, and then print their sum and difference. So now we have to actually print. We have to display the sum and difference of these 2 variables. So how do we do that?
So cout a plus b.
Oh yeah, good. That's probably good.
Line, and cout a minus b.
Exactly. Perfect. Doesn't get any more complicated than that. And then you're done, right? This is it. This is all you got to worry about. Really, all you have to worry about is just these lines right here. This stuff you always got to remember. That's just the bare bones of every program. And this is the stuff that's actually specific to this one. So good. Good. Yep. Let's do that again. Yes, that's right. Okay. And then we'll paste that right there. Good. Then finally, see the next one? We have write a complete program to read a number and then print 3 random numbers between 1 and that number, okay? So, inclusive. So, if what will happen is we're going to ask our user, hey, think of any number. And let's say they give us the number 10. Then we have to then print 3 numbers, 3 random numbers between 1 and 10, right? Right? If they did 9, then we do between 1 and 9. And then it says make it so the 3 numbers will print every time the user enters. Okay, the same 3 numbers. Oh, that's simple. That's simple. Okay, so make it so the user, make it so that the same 3 numbers will print every time the user enters the same limit. And explain what you should do different to ensure different results every time. Okay, so this will be almost a little recap. Let's first just worry about one thing at a time. Every time you see these projects or these questions, worry about one thing at a time because it's kind of a lot. So all we have to do first is read a number. Let's just worry about that. So reading a number, what do I gotta do for that?
Define a variable.
Right, defining a variable. Why am I saying define? Int, let's say int x. Okay. Now we have to read it, right? So how can I read it?
Cn.
Right. Cn, and then we just put in 2 arrows at x. And we're good. So now we've read the variable. So now we have to create 3 we have to just print out, right? Let's actually read it. It says then print 3 random numbers. Okay. So print means we're using what?
Cout.
Right. Cout. And then do you guys remember how to make a random number in C++?
That's a negative, my friend.
Yeah. It's not one of the ones that everybody usually forgets. Usually remembers. But it's really simple actually. All you gotta do is this. You need one class called, we're gonna say include, or one library called cstdlib. So C, but it stands for C, standard, right? And then library. So you need that. And then you can use this function called rand. So what you can say is rand, and yeah, rand, and now this will generate a random number. But the problem is it won't generate a random number between 1 and x. It'll end up generating a random number between 0 and I don't even know how large, like really large numbers, millions, right? So we need a way to restrict it. How can we only get it to generate a random number between 1 and x? So first, before we actually do between 1 and x, we have to do between 0 and 1 less than x, right? So if let's say x was 10, right? So what ended up happening is we need to first make this random number between 0 and 9 instead of 1 and 10. So we'll make it between 0 and 9, and the way we can do that is just saying mod x, which we'll say is 10 for now. So this percent sign, all it does is it's going to mod, which is basically divide whatever number is here, okay? But we don't care about what actually is the result of division. We really just care about the remainder. So if you remember from probably 3rd grade or 2nd grade math, before whenever you were dividing and you couldn't fit a number perfectly into the whatever you were dividing, you would have this thing called a remainder, right? So if we divide this random number we get by 10, right, and it doesn't fit in perfectly, that's fine. We just want the remainder of that. We want the remainder. So the remainder for dividing any number by 10, the remainder has a possibility of being anything from 0, a remainder of 0. That would be if like 10 fit into that random number perfectly. For example, let's say 10 divided by 10. That has a remainder of 0, right? But then let's say 11 divided by 10. That has a remainder of 1, right? So 10 can go in there one time, but then it's there's a remainder of 1.
So in the not parentheses, I can't remember what it's called. The markers there, I can't remember what they're called right now. But would you define how far out you want your decimal place to go, or how far out your numbers you want to go? So for say for example, you have a 3-digit number, you want it to be there, or is it? I can't recall.
A 3-digit number where? What do you mean?
So you want to see out, say between 1 and 10,
Mhm.
the random number between 1 and 10. If you want a single digit number between 1 and 10, you want it to be like, I guess I'm not understanding how you would get the random numbers to be what you want them to be, I guess.
Right. So basically, let's put it like this. Let me actually open up a mod calculator. It'll give you a better idea of what's going on. So mod calculator, the way it works. Let's say we have, all right, I'm going to put some random numbers in here. Right now they have 17 mod 3. Now if we calculate that, we're going to get 2, right? So the way it works is that 17 divided by 3, right? It's like 5 point something, right? If I actually pull it out on a calculator, not that calculator, and pull it out on a real calculator, we got here. Right? So if I have 17 divided by 3, oops, 3, there you go. It's like 5.666, whatever, right? So what I care about is that, if you remember, before you learn how to divide and then get a decimal, you would do remainder, right? You would say 5 and then however many you had left. So if I was doing this, let's just do an example. Let's say I had we had 17 in here, and then we had 3 out here. So you would say, okay, 3 goes into 17 5 times, right? And then you bring down your you multiply these together, you get 15. Then you do the minus. Then you're left with 2. Okay? And then you would say, okay, we have a remainder of 2 because you can't go any further. This is like the end of the line right here. You can't go any further into the number. So you have a remainder of 2. So we would say R2. Okay? That's the same thing we're doing here. And what you're going to find out is that no matter what this number is in here, the remainder can never be more than 3, or 3 or more. It can never be more than 2, really. So if we actually look over here, we see that the remainder is 2. Okay. Maybe let's change it to some random number, right? 312. Calculate. The remainder is 0. Remainder's okay. Wow, that's lucky. Remainder 0 again. Okay, remainder's 1. Remainder's 0. Remainder's 1. Remainder's 2. Remainder's 2 again. It's never going to be more than 2. Okay, so it can only be 0, 1, or 2. Okay, now if I change it to 10, now the remainder is 7, right? Remainder is 5. Let's say 9. Remainder is 9. Remainder is 1. Remainder is 3, right? It's never going to go past 9 though. Because we're modding by 10, Now the remainder could be anywhere from 0 to 10. Okay, so you can kind of see that every time, if we wanted to restrict, right, we take our, let's go back to our code, right? This random number, okay, if we mod it by our x value, right? Let's say our x value was 10. Let's say they entered 10 or 5. Let's say they entered 5. Right? Our random number modded by our x value will always return something, always end up equaling something that's 0 to 4, right? Because the remainder, if you have some ambiguous number and then you divide it by 5, there's only so many possibilities of a remainder. You can have a remainder of 0, right? You can have a remainder of 1, a remainder of 2, a remainder of 3, and a remainder of 4, right?
Okay, gotcha.
Yeah, okay, right?
Tracking now. All right, too easy.
So the problem now is we only have one less problem. We're right now we're only making numbers between 0 and 4, okay? But we need 1 and 5. We need from 1 to 5 because that's what they entered, right? 1 to 5. So it's actually a pretty simple fix. All you gotta do is say +1, right? And what this is gonna do, if we got 0 here as a remainder, we would add 1 to it, and now we would have 1. And then if we had 1 as a remainder, it would go to 2. And if we had 2 as a remainder, it would go to 3. If we had 3 as a remainder, it would go to 4. And if we had 4 as a remainder, it would go to 5. And of course, we can never get 5 as a remainder because it already stops at 4 as a remainder. And so now, just adding this +1, we kind of shifted. We shifted the whole range from being 0 to 4. We've bumped it up to 5, from 1 to 5, right? With this +1. So that's basically it, right? That would generate one random number between 1 through 5. So if they said we have to do this, how many times? They said they had to do this 3 times. Yeah, 3 times. So it's pretty simple. If you want to do 3 times, you just copy and paste the 2 other times. Right? Now, if we run this, let's actually run this real quick. Let's build the task. Okay. Good. Okay. Now, I don't understand why my terminal is so big. There we go. Okay. Temp. Okay, so now it's waiting for input, right? It's in the input, waiting for input stage. So I'm going to say 8. Okay, and I probably should have put them all on end line, right? Put an end line after them. But you can see that it generated 2, 4, and 7, right? Okay, 2, 4, and 7. Let's do it again. So I'll put 8 again, okay? 2, 4, 7. Let's do it again, one more time. If I put 8 again, it's going to keep generating 2, 4, 7. So we can already see, we actually already meet the first criteria. That if they make it so that the same 3 numbers will print every time the user enters the same limit. So I entered 8 as the limit, and it keeps printing 2, 4, 7. That's because on default, C++ will not generate, well, it'll generate the same random numbers basically every single time, right? It always generates the same random numbers. Now, if I put 3, let's say I put 3, now it's going to, yeah, it'll generate 3 different random numbers, right? I changed my limit to 3, so it printed 3, 3, 2. But if I still do 3, it says 3, 3, 3, 3, 3, 2, right? I do it again, 3, 3, 2. So the limit 3 has its own random numbers that it's always consistent. 8 has its own. If I go back to 8, it still does 2, 4, 7. If I do 5, or 6, I guess I did 6, it'll be 6, 6, 5. So these will never change though, right? So on default, you don't really have to worry about it, right? You just have to remember that rand already is consistent. It'll always generate. Rand is always the same. Whenever you restart your program, it'll always generate the same random numbers. But then she asks, and which is important, all right? Explain what you should do differently to ensure different results. So basically, I don't know why I gotta be so complicated about it, but all you gotta say is, what would you do differently so that way when you entered 8 as the limit, it would be different every single time, right? It would print different numbers every single time. You would never get the same numbers. So it's very simple, very simple. It's a matter of just adding 2 lines. So we're going to add a library called include ctime, which ctime is like a library all that works on little calculations on time, right? And then you're going to add this one line right here. We're going to say srand, which means like set random. We're going to set the randomizer, okay? We're going to set the randomizer. And all we're going to put in here is another function called time 0. So it's saying set the randomizer to be based off the current time, right? Time 0 means the current time. So set the randomizer to be based off the current time. Obviously, the current time is always changing, right? The current time right now is different than now. So these should be different every single time. Now, you don't have to change anything over here, right? Rand is now going to work based off this. And we should actually see a difference. So let's actually build it. And let's put 8 this time. So now we put 8, but we got 2, 2, 3. So let's do it again with 8. Now we have 1, 1, 4. More time. 3, 6, 3. Or sorry, 3, 6, 5. So as you can see, and then we got 6, 8, 6. So it seems to be different every single time, right? If we did the same thing with the other numbers, it would still be different, right? And we could do this for bigger numbers too, right? Let's see, 321. And we get these numbers, right? Pretty big. They all still work though. So yeah, that's kind of what am I going on about? That's all you would have to do to ensure actual random numbers, right? It's a matter of just adding this line and this line. Sorry, no, this line and this line, right? So let me actually get all this. Was that clear?
Yes.
Clear as mud.
And I apologize. I missed the first maybe 5 minutes of the lesson today. But will the format of the test be just like we're showing here, like a word? Well, I guess questions with free form answers.
Yeah, well, yeah. They'll be free form. At least like I think this is all gonna be on Canvas, right? Or this will be online if you're taking it
Uh-huh.
online. So this should be like text boxes, right?
Okay.
And then these should be like also I think text boxes, right? Because it'll say what is the term hardware referred to, and then you'll have like a little text box where you can just type it in. These will there's some of them I believe will be multiple choice. I'm not sure. I have to check again. But I can check. But yeah, it should be basically like that. A lot of it will be free form. Um,
And these standard libraries that you use, like the CSTD library and
the C time.
the S yes, the last one. Those I don't think I've read ahead to see how those libraries are defined, but those are within the reading.
Yeah, for sure,
Okay.
for sure. Yeah. Okay. So it will say, this one's for non we'll call it non truly random. And then we'll call this truly random. Right, which is basically what the first part is. The first part, let me review layout. There we go. Okay, so yeah, the first part where she's asking, make sure it's the same numbers every time. They enter the same limit. That's what non-truly random would be, right? Which is just when it's basic, when it prints the same numbers every time. Then we have truly random, right? Which will have srand, of course, and the ctime, which will print different random numbers every time. That'll be the truly random. Okay. Yeah. I don't know why anybody would make a document like this. Okay. Fine. So fine. Okay, so now we're on to the easier part, right? What does the term hardware mean? Okay, now these questions might sound a little more complicated than they actually are. Why? Why is it doing this? Okay, maybe. Okay, well, I'm not sure. I'll figure that out later. Actually, I'm going to put it to the side. So, the term hardware. Any ideas? Any ideas?
The part of the computer that helps it do its job.
Like the physical part, right? Think about
Yeah.
this. Software, you can't touch it, right? It's kind of just like it's like code. You can't touch code, can you? No. Hardware, they call it hard because you can touch it, right? You can actually feel it. Like the keyboard, that's hardware. Your mouse, that's hardware, right? So we just call it the physical parts. So we'll say physical parts of a computer. Yes, compatibility mode. Okay. All right. Sorry. At the heart of a CPU is a central processing unit. Let me actually check this. These questions here are kind of like you just have to remember them. I would say here's how you should do this, right? For these questions, try to remember them as best as you can, but don't. After this test, I don't think you need to worry about memorizing them so much. I don't remember if they have it on the final as a deal. I don't think they do. I don't think they do. But after this test, I wouldn't be too worried about remembering things because they're not that important, especially for future stuff. So let me just check the solutions for this. Yeah. Okay. I use such weird lingo here. But basically the job is to do this. It'll be okay, I guess that's fine. The first thing it does is it gets instructions. Okay, that's the first part. Then it It basically does operations based off the instructions, right? So it gets the instructions and then it reads them, and then whatever the instructions tell the CPU to do, it's like, okay, I'm gonna go do it, right? So then it does them, right? So it does the operations based off the instructions. Yeah, and all of this is it, and then it produces some result. You could just say produces some result, which is kind of redundant, but whatever. Result. And that's basically it. That's all it does. So, next one. Okay, the computer's main memory is commonly known as, this is pretty obvious. This is just RAM, right? Whenever you hear of RAM, your computer doesn't have enough RAM, right? That's all that is. So, nothing crazy. What are the parts of the CPU internally?
I think it's the arithmetic.
Yeah.
Uh,
The arithmetic and logic unit, and then the control
yes.
unit. So, If anybody asks you what they do, I don't know if they do. I've had somebody ask before, I think on a test. I don't remember. But the control unit, we'll say the control unit does like the decision making, right?
I think the control unit does like the fetching of like grabbing
Yeah.
the data. Yeah.
Yeah. And then like the arithmetic, right? So the control unit and arithmetic and logic. That like does all like the work, like the calculations. Logic. Wow, which is very actually interesting. Okay. Arithmetic and logic unit. That's basically it. So the arithmetic, it's in the name, right? It does the math, right? And then control. This one does all the decisions. Okay. How much data can be stored in 1 bit? That's a really strange question. Oh, yeah. Okay. Fine. I understand the question, but fine. Okay, so really, in reality, first, what is a bit? Anybody remember what's a bit? All right, so bit is the it's basically just the ones and zeros, right? The ones and zeros are all of those when you hear, you see in movies, ones and zeros, right? It's bits, right? Those are all bits. We call each one or zero a bit. Now, how much data? The question is, how much data can be stored in 1 bit? Well, every time you see a 1, that's a data. Every time you see a 0, that's also data. So a bit can only be one or the other. So in reality, you could say, how much data could a bit store? Well, it can, and the answer that they have here doesn't really make sense. But technically, you can only store 1 bit. That's the amount of data it can store. But it can hold 2 different values, right? So a bit holds 2 different values. Kind of a weird answer, but that doesn't really tell me how much. I guess I know what they mean, but it's still not a size. But okay. Then a byte. Now a byte is simply a byte is composed of 8 bits, right? To make 1 byte you need 8 bits. That doesn't mean though that it's now holds 16 different values because right, the way a byte works is it's a line of 8 ones or zeros, right? Ones and zeros, right? And those ones and zeros can be organized in any different way. And each new way is different than the last, right? It's going to be, right, they have to be different. If they're different from the last, that's a new order. Now, each order counts as one value, right? So 0, 0, 0, 0, 0, blah, 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 is one value. Then 1, 1, 1, 1, 1, all the way is one value. Then 1, 0, 1, 0, that's different, right? So at the end of the day, right, it's basically 2 to the 8th power is how many, which equals what? 256, yeah. 256 values. That's how many values a byte can represent. That would be a better question. How many values can 1 bit represent and 1 byte represent? That's a better way to forward the question. But whatever. Okay. How many bytes are used for short integer and integer? Yeah, I'll just say this one. These are questions I don't think matter. So, short integer is equal to 2 bytes. And if you're not sure ever, I'll show you how to find out instead of going through your book, which is will take way longer. So integer is 4 bytes. Okay. Now, what you can do if you don't remember, you go over here, you go to Google. I'm just gonna say integer, or say size of int in C++. And they have short int. They say the size is in bytes, 2 bytes. Integer is 4 bytes, right? And that'll give you a quick refresher. Make sure to always say C++ though, not some other language. In other languages, it can be different. All right. Now, next question. Maybe this will be more interesting. Okay. If you need to take your program to a different computer, okay, your C++ program, maybe your Hello World program, would you take the source or the executable? Under what circumstances would the answer be different? Now, yeah, this is one of those questions. Basically the answer is you would typically you can take your source. Sorry. Yeah, no. You always want to take your source, right? That's like what you actually typed, right? The executable is like machine code, like ones and zeros, right? That's like a file made of ones and zeros. You don't want to do that. You don't want to take your ones and zeros file, the executable, because different computers can sometimes have different machine code, right? And so, it might what the executable that works on your computer might not work so well on another person's computer. But C++, right? You typed hello world on your computer. You know you can type hello world on another computer. So if you typed it on this computer, chances are it's definitely the same on another computer because C++ is universal, right? It works everywhere, right? I don't think hello world program has ever not worked somewhere. And so you would say for the most part you'd say source, and we'll just say if completely different program. If completely different computer. If you're taking your code to a completely different computer, completely different, then you're going to take your source, which is just the stuff that you actually typed. Okay, what is Iostream? So this is actually important. This is a good one. So what is Iostream? Anybody remember what it does?
It provides I guess the library definitions for cout.
Without it, you can't do things like cin, cout, or endl. Can't do that. And so, yeah, that's basically it. I guess, yeah, they call it, what it's called is the library for standard input and output, right? So, library for standard input and output, and then they have something. Yeah. So, it's the input output library. You want to input, you want to use cout, you got to use Iostream. If you want to use cin, you got to use Iostream, right? All right. 15. What starts with a pound symbol?
A preprocessor directive.
Yeah. Which is just, I don't know why they gotta use such, it's just a library, right? A library, I'll say a library, or directive. Those should just work fine. Preprocessor directives, it's like overly technical. Okay, the linker. Let me see. Okay. So anybody remember what the linker does?
I'll take a stab at it. The linker, that's what adds those libraries to your source code.
Yeah, exactly, right. So like your source code without them, let's say your computer's reading your source code, it's gonna look at your cout. It's like cout, where's that from? So it's like, hey linker, tell me where the cout's from, and then linker's like, okay, so you're gonna go get it, right? The linker tries to find out where it's getting. It goes to, it looks at the included libraries that it has in the code, and it says, oh, I found it over in the Iostream library. So what it does is it links those two things together, basically imports it. Yeah, so yeah, exactly, right? Links libraries and pieces of your code, right? So it links the libraries to your code. That's about it. Okay, here's a good one. Assuming you are using a system with 1-byte characters, that means every character inside of a string, right, inside those quotes. So every character has a size of 1 byte, right? Its size is 1 byte. How many bytes of memory will the following string, so this string right here, we have however many characters, you can zoom in. How many bytes of data does this string take up? Any idea? So it's pretty simple. Pretty simple, actually. Let's actually just count how many characters we have. We have 1, 2, 3, 4, 5, 6, 7. 7 characters. Now, it's not 7. The answer's not 7, right? Not 7 bytes. So, but right now we have each character represents a byte. That's 1 byte. So 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte, 7 bytes. Now, the answer is actually going to be 8 bytes. It's going to be 8 in the end because there's actually one character you don't see. There's one character you don't see, and it's not really a character like a letter like we think of. It's more like a character terminator. And what happens is this character terminator comes at the end of every string, right? It tells like your program that you've reached the end of a string, but you never see it. But you still have to account for it. It still takes up the amount of it takes up a whole byte of memory. So you just have to remember the way to calculate is always count how many characters there are, add 1 to it, and that's the size in bytes of your string, right? That's how much your string takes up. However many characters you have, plus 1. All right. What is the range of integers in C++? Okay, well, before that, actually, do you guys remember how many bytes are in an integer? That's fine. That's fine. Don't worry. I don't typically remember. There's 4 bytes in an integer, right? So we're dealing with 4 bytes in an integer. Now there's 8 bits. If you remember, there's 8 bits, okay, in a byte. So how many bits do we have in this integer? If we have 4 bytes in an integer, we've got 4 bytes in an integer. And there's 8 bytes, there's 8 bits, right? 8 bits in a byte. Then that means we have 32 bits in a byte. Sorry, in an integer. There's 32 bits in an integer. So using all this information, we have the number 32. So what you can do with this number 32 is first minus it by 1. We're going to have 31 now. And we're going to say is minus 2 to the power of 31. And then we're going to put a little dash, right? This is the range, all the way to 2 to the power of 31. And minus 1. Okay? So we have negative. So this is our range, right? We have 32. We got that number 32. And we said negative 2 to the power of 31, all the way to 2 to the power of 31 minus 1. That's how you can find it. That's always how you can remember. So if you want to do the same thing for short, right? Short is only 2 bytes, right? 2 bytes. So it has 16 bits. 16 minus 1 is 15. So you would literally just replace this part with 15 and this part with 15.
Okay. The question on why we're subtracting the minus 1.
The minus 1, right, is because you have to remember 0. 0 is in here somewhere. And
Got it.
and when they were right, so somewhere in there is 0. And they decided to make 0 part of the take 1 away. To make space for 0, they had to take 1 away from positive, right? Okay, on to 19. Okay, give examples of different operating systems. I don't even know why this is a question. I'm just gonna give you. We got iOS, we got Android, we have Windows, and of course.
Now this sounds dumb, but for our test, will it be like this many questions?
I don't think. No. I've seen it. It's not that many questions. I think it's only it's probably like half of them, maybe half the size, maybe even less.
Yeah.
But it's not this many questions. So
And are we allowed to reference everything, or do we have to memorize all this verbatim?
yeah, I don't think she's doing open book. So this part you're gonna have to kind of just remember. I would say for this part, just like do flashcards. After this, the good thing is after this test, I don't think most of it is the next tests are not so memory heavy. Just remembering random facts, but this one kind of is. And so I would just try to remember somehow these ahead of time. Once you remember them, they're not that difficult, but it's just trying to remember them. Okay. And we'll do these last few. So let me actually see the answer to this because I don't know what this means even. Okay. Explain the difference between an application program and a utility program. So all that is like an application program is like the definition is programs that allow a user to perform a specific task on the computer. I guess it's like programs that the user kind of is involved with, right? So like Word document would be one, playing a game would be one, right? Google Chrome would be one, right? Basically all these at the bottom here on my desktop would be one, right? And so I would just say like application program, just leave it at that. Application program, programs that allow the user to perform specific tasks. Perform. Okay. Then we've got, of course, what's it called? Utility programs. Utility are like the ones that the user doesn't. Wait, yeah. He doesn't interact with utility programs. So things like type of software that performs a specific task, usually related to managing. Yeah. Performs a specific task. usually related to managing, maintaining the computer system. Many utilities are built into the operating system. So I'll say something like that along the lines of the programs that perform a specific task. Already you can see though, it's like perform a specific task. That's very generic, and that's why it's like almost exactly the same thing as this definition over here. They're almost exactly the same, except this one has the user involved. This one does not, right? I would say maybe say user independent. And its tasks are usually to help what? To help maintain computer system. The computer system. And I think that's good enough. That should be good enough as a definition. So these ones are kind of ones that are running in the background. You could think of that, right? So if I looked up, let's say shift escape. You could see a lot of these here are running in the background. You see all these programs stuff running in the background, right? The processing, the Intel, right? Obviously, I'm not interacting with that. But then we got stuff like Word document here. That's an application program. Those other ones in the background I don't really work with. Utility, right? And then give some examples of high-level languages. The last one we'll do. So obviously C++, right? C++, Java, Python, Ruby, and then that's enough. You don't need any more, right? Now, let's explain the difference between an error and a warning. Say so this one's really quick. An error, if you run your program with errors, your program will stop because it'll basically like break, right? It'll just like break. But a program with warnings, they're just warnings. They don't necessarily they won't break your program, but it's telling you, hey, you have a chance of accidentally creating an error with these warnings. And that's basically it. So any questions on any of this so far?
I had a question. So I kind of joined late. Because I had to do some. I want to know, is this recorded or no? It doesn't seem like it was recorded.
No, I'm recording it. I'm recording it right now.
Okay, cool. How would we end up accessing it?
Yeah, so I'll probably be making announcements. So actually, let me just stop recording right now.